So, the idea is to build an entirely 3D printable candy dispenser, or otherwise known as Gumball machine, but I don't want it to only work with gumballs. What I have thought of to make this idea a reality is just to simply have two gears. One will be attached to a turn handle, and the other one will move the candy from one place to another, while using the rotation of the handle. I have built something similar before. The only difference being is that it's not mechanical, but instead controlled electronically by a stepper motor and an Arduino. So how hard can it be? Also, I want it to be coin activated. To make that work, the handle can turn either way if there is no coin in it. Then if you put a coin in, it can only turn in one direction, has to eject the coin, and needs to block again if the handle has been turned one full rotation. So let's jump into CAD and I'll show you what design I came up with. Looks pretty promising, right? Well, no. I had to do many design iterations to the coin mechanism for it to finally work reliably. But now that it functions properly and the design is more or less final, let's explore how it works in detail. First, we have the turn handle, which is connected to these three pieces and reaches through the two plates. The first one is the cover plate. Its job is to cover the mechanism. Also, it has many screw holes and the cutout where the coin is later ejected. The second plate is the back plate. It also has many dedicated screw holes and cutouts for the coin lock to bend all the way back, and another one to adjust the coin lock's tension. In between the two plates, you can find the coin disc and the previously mentioned coin lock. A coin perfectly fits into the coin disc and will engage the coin lock, so that the disc can turn clockwise. If there is no coin in the slot, or if the coin has been ejected, the coin lock will be pushed against the side of the cutout and therefore block the disc from turning clockwise. What about counterclockwise rotation though? That is what the ratchet gear in the back is for. It can only be turned in one direction because of the pawl, which can easily be pushed out of the way by the slopes if the ratchet gear is turning clockwise. However, as soon as you try to turn it counterclockwise, the pawl will engage with the gear and block the rotation. The whole mechanism relies heavily on gravity. If it's not standing upright, the pawl will not engage with the ratchet gear properly and the coin will not fall out, allowing for infinite candy. So we got that covered. Now, let's turn our attention towards the dispenser mechanism. This one is far less complicated. Basically, it's only the two gears. The small one is connected to the turn handle and the big one sits at the bottom of the candy reservoir. They have a 3:1 gear ratio. So if you turn the handle one full rotation, the dispenser gear will turn 1/3 of a rotation. Since it also has 3 cutouts for the candy to fall in, each full rotation of the turn handle will correspond to one slot full of candy being dropped onto this ramp, from where it slides down to the hole in the front of the machine. Also, this part allows customization of the slot size, so it works with different kinds and amounts of candy, depending on how generous you're feeling to the little kids. Besides all the mechanical parts, you have the case, where all the coins and candy fall into, and which houses the mechanism. Above that, you have the hopper, where the candy is being stored. Now let's print it and assemble everything. printed the smaller parts with my usual settings and the big case with some rather unconventional ones. Otherwise it would have taken 1.5 days, but I'm really impatient, so I managed to cut it down to 13 hours using these settings. Notice how the layer height is well above the recommended maximum height for a 0.4 nozzle? I thought that might be a problem, so I increased the extrusion width to 0.52 to simulate a bigger nozzle. I also used a temperature of 230 degrees, which is 25 degrees hotter than what I normally print with, so my hot end could keep up with the volumetric flow rate. To my surprise, and besides these sketchy settings, the part actually turned out quite nice, except for the section where I ran out of filament and was under-extruding the new one because it needed slightly higher temperatures. But after turning up the temperature by 5 degrees, it continued to print fine. All I used for the assembly were the printed parts and some M3 screws and threaded inserts. Don't have threaded inserts? What are you even doing with your life? They should ship them out with 3D printers. You can use them with absolutely everything and they're super cheap. Anyways, back to the machine. See how the mechanism works absolutely flawless? You can't turn the handle in either direction, but as soon as I put a coin in, the handle can be turned clockwise, and after a full rotation, your candy is dispensed and the handle locks itself again. Nice! Why buy something when you can do it yourself in a worse looking version and put a massive amount of effort towards designing it? Still, what can go wrong will go wrong. After some time I noticed the handle was jammed when it shouldn't be. Turns out it was because the hopper was unfortunately shaped and this edge was just a magnet for candy getting caught. So back to CAD and fix it. By the way, if you have a 3D printer, all the 3D files can be found on my Thingiverse account, together with some more info regarding the assembly, as well as a step file of the whole model. The link is in the description. That's it for this video. If you enjoyed it, give it a like and consider subscribing.